Second, I really don't have a whole lot to say at the top of this other than hopefully everyone signed up for our March meeting. So a month from today, I think, it'll be on a Tuesday for this particular meeting. But in this room, we have Carl Franklin coming to speak on Blazor. The only real difference for that meeting is that we're aiming to start at 6 because apparently he has like 3 hours of material and you don't say no to Carl. So we're going to try to get going kind of right at 6 and give him all the time he needs. And then, he's got to get on the road to go to the next city right after that. So
who is Carl?
Carl is, one of the oldest big names in the .NET ecosystem, I would say. So if you've ever heard, he's the .NET rock star. So if you don't know who he is, he's one of the main guys from the .NET Rocks podcast. He's been around for a really long time, has written 1 million books. Super smart guy, really nice guy. So it should be a really exciting meeting to have. Beyond that, we should hopefully have something up soon for April. But always feel free to reach out if you're interested in giving a talk or a lightning talk or anything. Looking for stuff. And I think that's all I got. So I'll hand it over to Trystan.
Thank you. So a quick word about where we're at. This is currently the LADOTNET home, and we are looking for more locations, but Verizon Media is proud to host LADOTNET. And in particular, Trystan Hill presenting on resilience engineering with Poly. So we are a CDN with video lifecycle stuff on top. Currently, right now, we are live streaming this presentation. And we streamed the NFL, the Super Bowl yesterday. There was some very impressive stats. Some 4K HDR content was being streamed. And multi-camera, so on one device you could have multiple camera angles on the field. And this was all getting pushed over for real 5G. And so you could watch multiple camera angles at once and flick between each one. So yeah, we're a cool CDN, lots of data, lots of interesting stuff going on here, so feel free to investigate us and investigate our engineering blog page. Is there an easier URL for that? eng.vdms.io. This is a... Oh yeah, don't forget. All right, I'm going to get started. So I'm going to, as I said, I'm going to be talking about some resilience engineering using the Poly. Well, I'm going to be talking about some concepts and how to tackle them with the Poly library. This is me. If you don't know me, my name's Trystan Hill. I work here. And basically, I'm going to be talking about when we are building applications, we always think about hello world, happy path, making an API, getting a website up, it works, throw it out into the production, see what happens. But I guess the sort of the main thrust of my talk today is that in the real world, all kinds of things can happen. At various different levels, things can go wrong. So resiliency engineering is really about building with real-world stresses in mind. Can you write software that can withstand pressure? Similar to how people, like engineering and with a bridge, they don't just build a bridge that's not ever going to move from the Earth's harmonics. They want to add a little bit of wiggle room to it, so that it can absorb some stress and not just completely fall and crash. So similarly, we want to think about our systems when things aren't going spectacularly. So this is a crazy diagram of someone's interpretation of what Uber system might look like. I'm throwing it up here to give you an idea of the design complexity of the architecture of these systems. It's no longer just one big app. You have, on this example, we have a dispatch service, a trip service, a payment, and a user profile. And then you'll see on the right thousands of microservices. And that's to support Uber's I mean, relatively simple idea of I want to get a ride somewhere. So it's not even as an idea, relatively simple as this. You know, I mean, they are huge. I'm not saying what they're trying to do is not complex. It's just today's systems are no longer one big box chewing a bunch of data. So yeah, nothing to get lost in this. Just wanted to give an impression of, you know, the distributed nature of systems these days. I seem to have jumped ahead. So in my previous example of Uber, what would happen if the payment system was unreachable for a period of time? Should riders and passengers and drivers not be able to use the app, and not, should the whole Uber service go down? Even if it's for 5 minutes. You can imagine that that's probably an unacceptable position for Uber to be in. So they might have a resilient strategy on that case of having a queue or a stack somewhere where, oh, the payment service wasn't reachable. Let's add it to a queue, and they'll pick it up and process it once it comes back online. So that's just a basic, simple example there. So mainly going to be talking about transient errors in this case. We have a list of them here. And I was wondering if I could get some input from people. If I was going to run through this list, can anyone think of what a transient network outage might be? So maybe something like a strange little network blip. Because I have one here. I know Sadai knows one. Someone, every now and again, there's something on our network that will reset TCP connections when...
Oh, like TLS
right.
issues? Yeah.
Can you, I'm going to put you on the hot seat. Can you think of any other transient HTTP errors?
I don't know, maybe the service is just temporarily unavailable.
Yeah, so maybe you get like a random 500.
Or something like that.
Yeah, uh-huh.
We get those. We have a building about a mile away from our main building. They often call it to see that, say the main app is down. Oops. They call and say they're about a mile from us. They call and say the main app is down. By now we know it's just a network issue.
Oh, nice. And so that's transient, and then after a period of time it comes back up?
Yeah.
All right, and so a service outage. Anyone have a clue what I might be looking for there? I'm just going to feed you then. Something maybe like a third-party notification system. So maybe on user sign-up, part of that is to send that user an email saying, here's a link and all this other stuff. You don't want the registration to completely fail and the user have a horrible first-time experience if the email provider is not contactable. So a service outage might be something along those lines. Denial of service attacks, kind of obvious. If someone's getting hammered and someone's actively trying to take them down, they might be hard to communicate with at that point. I don't know if anyone's had any experience with that firsthand, but as a CDN, we're constantly being attacked by various different agents. And I went to some security trainings, and the way they categorize all the different levels of threats, it's really interesting. There's one for political. I didn't think we'd ever be for real having political attacks on our networks, so that was kind of interesting. Anyone got an fake news? Anyone got an idea on what IO locks might be in terms of transient errors? That's exactly what I was going for. Thank you, Atan. Deadlocks. Or a connected device failure, Atan. You wanna scream out there as well? Ah, nailed it. So I guess I was imagining a system where there's many sensors, maybe like an IoT device that's measuring the temperature of this room, and for some reason that's an important measurement, and it reports up to some master server. Now, how does that master server react if those little sensors aren't replaying? So these are some kind of high-level ideas of transient errors. Just to give you an idea of kind of where we're heading. I'm seeing some nodding heads. All right, so the library to tackle some of these, I'm going to be talking about Poly. It can run in anywhere you can run .NET, well, mostly anywhere. anything in the last 10 years. And in a one-sentence description that I have masterfully stolen from their GitHub page, it's a way of fluently expressing transient exception handling policies in a thread-safe manner. And each one of these, well, 90% of the words in that sentence are important. Fluently, we know what that is when with the link library, we're able to chain method invocations. Transient, we went over that. Exceptions are the .NET idea of something's gone wrong. And thread safe, meaning that you're dealing with concurrency and you are taking into account of race conditions and the idea that multiple things might be happening at the same time. So if you want to check it out, this is their GitHub page. And if you want to install it, it's simple as installing it via NuGet. So the main strategies I'm going to be talking about, which when I was looking at it was I believe this is the full list that Poly supports. It grows. It started off with a lot less than this, half. So I'm going to run over these quickly. I'm going to go into some more details on each one as we go along. So retry is that nice, simple one of maybe it was just a one-time thing. Maybe if I retry, it'll work. Timeout is basically boxing how long you want to wait. You don't want to sit around and wait 30 seconds. You want to say, this call, if it takes more than 5 seconds, give up on it. Circuit breaker, this one's sort of like the pragmatic health monitoring of a downstream service where you can basically define what a threshold of failures. So 3 of these kind of exceptions in a minute's period, and I've decided that this service is no longer healthy. Don't even waste my time. Fail as fast as you can. The next one is bulkhead isolation, which is, the metaphor is from a ship, and it means that you don't want these errors to build up and cascade and take down your whole boat. If you have a small breach, contain that damage and keep floating. Cache, I think everyone probably knows a bit about what caching is, but it's just a simple way of remembering a particular request from a remote service and saving yourself some time and delivering what you know to be the same content. And fallback is when everything else has happened and it's not going well, so how do we fail gracefully? What do we want to... A lot of the time it's just how do we want to give our users the best possible experience when things aren't going right. So each one of these things is great and powerful on its own, and each one you can spend like days, weeks configuring and playing with and tuning and getting just right. But it's when you start combining them together, that's when things become really a bit more powerful. So this fella here is an example of multiple protection. I went with the WorkSafe version of that, and this guy's got 2 helmets. I found out it's because they don't want the real visor damaged while he's on Earth, so they have like an Earth visor and then a outer space visor. All right, let's dig into the first one, retry. Seems simple. Everyone's done it. A lot of people have, I'll admit that, a lot of people have dealt with retries before, where, like you were describing, you're a mile away issue, or I know with a lot of the times we have some strange agent on our network that will reset TCP connections if it detects what it considers to be an insecure TLS handshake. But it happens so infrequently that a retry usually solves it. It's inelegant, it seems brute forcey, but you'd be surprised at how often a simple retry can keep service running smoothly. So I have a bit of code here to maybe illustrate kind of what that would look like in code. I just have a for loop, simple as a for loop with a max retry count. So that for loop is going to be our mechanism for looping. And as soon as a non-successful status code is returned, we do a delay for a period of time. In this instance, we're waiting 10 milliseconds and then trying again. So it's as simple as that. To add on to that, let's talk about some of the delay strategies. So in that previous example, I had a static time period to wait. And sometimes it's not the most appropriate thing in the world. If a downstream service is struggling, piling on retries, you might be pouring gasoline on the fire at that point. They're already struggling, so you don't want to just flood them with, what one request has now turned into 3. So if you got 1,000 requests, that might turn into 3,000 requests for your downstream service that it has to handle when it's struggling. So Poly has a nice way of letting you do exponential backoffs or delays. So in this example, we are explicitly we've got an array of time spans. It'll let you can say, well, it's pretty clear. You're waiting 1, 2, 4, 8, 15, and 30 seconds. There's other ways of doing that. In this example, I'm using the retry iterator multiplied squared to get the time span. So on the first time it tries, it's going to wait 1 second. On the second, it'll wait 2 to the power of 2, which is 4, and then the third, it'll become 9. So in that way, we get that exponential number series. So with these things, a lot of the time, just exponential backoff is enough to give yourself enough clearance room and give that downstream service a chance to respond well. But if you are dealing with a lot of things coming in all at once, and especially if you know that they're coming in at a particular point in time, you don't want your retries to all come at once. So we have an idea of adding an element of randomness to the delay period. And I think the usual nomenclature people use is jitter. Jitter. American accent version is jitter. There you go. So in this example, I'm using Poly, or maybe I should go over those, that'd be good. But you can see I have using that random class to tack on a random period of time from 0 to 1 second there. It might be good to quickly, now that we're seeing our first taste of Poly, is this anyone's first time seeing what Poly's policies look like? Okay, great. Since this is the first time, we're instantiating a new policy here, and we're telling it what kind of exceptions we are interested in. So just in a similar way you would have a try and a catch and a particular exception type in there, think of that as essentially how that catch is working. So we're interested in only in some exception type, and then we're doing a wait and retry here. Same for this. Oh, these examples are pretty straightforward. So you can chain that, you can add more on, and I'll have more examples of this later on. But anyone got any questions on retry and exponential backoff and jittering, anything like that? Jittering stuff? Cool. I think of that as a relatively optimistic approach. So we're going to move away from something where you're hoping it to get better by itself onto probably a more pragmatic and realistic approach. To timeout, this one's nice and simple. Again, we're using this Poly, and we're creating a new timeout, setting it to 30 seconds, and then when that timeout happens, we are logging that. So I'm not sure if I made it clear before, but this code is not the most amazingly complex algorithm in the world. You can always implement your own timeouts. You can always implement your own retries. But this is Poly's way of having a unified, and in my opinion, once you get used to it, quite readable and organized way of handling all these different types of things. So yeah, this one's pretty simple. Does everyone know what a timeout is in terms of making a request and hanging on? Great, so let's move on. So Poly gives you 2 modes. And if everyone's dealt with some async code before, you know a lot of times you'll pass into your delegates an cancellation token so that when everything is playing nice and as your delegate should be and respecting that cancellation token pattern. Everyone knows what the cancellation token pattern is? Where that I want to cancel some downstream delegate, and so it has a token that I have access to, and the upstream can cancel out that downstream. So if that downstream job, for example, is some for loop and chewing over some information, somewhere in that for loop it should say, hey, is my cancellation token, have I been requested to stop? And if I have, then exit out gracefully. So I think that's the key here. The optimistic mode is you know that your delegate's going to respect cancellation and going to exit gracefully. If you know that it won't, or if you have a hint that it won't, you can be pessimistic and you can forcefully terminate it. Oh yeah, it doesn't work. And that just means essentially you're not going to wait around. You basically kill -9 that thread. So this one's an interesting one. This circuit breaker analogy is to a electrical circuit. And the idea is you're keeping an eye on the health of some code. If it starts failing in some specified way, you keep track of that, and once it's reached a particular threshold that you define, it cuts power. Or in this analogy, same analogy, it opens the circuit and electricity does not flow anymore. So it's basically like flicking that light switch off and the lights go out. Just like, actually, that was well timed. Right, and so the goal here is, A, for yourself and for your service, you don't want to exhaust your time waiting for these downstream services that you have a pretty good inclination aren't returning or aren't working right now. So you're going to save yourself some time and fail as quickly as possible. So an example might be a simple HTTP request, and it might take, let's say you've configured your client to time out after 3 seconds, which is, in computing, a very, very long time. So if you know that that circuit's no good, cancel, and you've just saved yourself a huge amount of time. And that's true for every request that would have happened to. So the savings add up very quickly. So yeah, it has, I guess, any questions on sort of that concept and how it works and why we're trying to save time? So it has 3 states. Closed is when everything is good. Calls down to the delegate are made, and everything is happy. And we move from that happy state to the sad state once a particular threshold has been met. And the threshold is similar to that retry exception. You're going to be defining, what am I looking for? Some kind of exception, and you're going to be saying, well, how many of them are you interested in a particular period of time? So if I get 3 connection exceptions within 2 minutes, I have decided after tweaking all my knobs and dials that means that this service is struggling. So at that point, we're going to move to the open state. Open in an electrical circuit means electricity is not flowing and that the calls do not get made. They will instantly fail with a circuit breaker exception. The exception gets bubbled up and circuit breaker will immediately throw an exception. So the other piece of configuration we have with circuit breaker is the amount of time we want to wait before testing the waters. So at some point we want to close that circuit again. We want calls to get made again, but how long we wait until we test the waters is that delay. And so this half-open state, once that time period has elapsed, we're going to watch that. We're going to let one execution go through, and the result of that execution will determine whether we go back to closed or open. So if an execution fails, we know this downstream service is still no good. Head back to the open state for another delay period. Or it was good, let's open up the flood streams and let things roll through again. So it's really powerful and really cool. And I have some stuff I don't have some stuff in my demo, unfortunately, about this. And so hopefully no one has any questions so far on this, because sadly left this one out of my demo. Yes, Paul.
Maybe it's a question premature, but how do you connect Polly to your app?
No, that's not premature. So the question was, how do we connect Poly to your app? Did I summarize that?
Yes,
Yeah,
correct.
so there's numbers of ways of doing it, and there's lots of ways of organizing that. To start with, you have to install that NuGet package. Now, depending on what kind of app you have and what kind of architecture you're using, it can be a good organizational pattern to use it in your dependency injection setup, so that I'm not sure if you've kind of got the gist, but it's not like it's not the most readable code in the world. So, and also keep in mind, it's very easy to get these things wrong with all the little knobs and dials that you want to adjust. So a lot of times you probably want that in one central location and have an easy place to look at them and manage them and that kind of a thing. So at the place to configure all this stuff might be in the dependency injection, like the startup of your app. Is that kind of what you were looking for?
Yes.
Okay. I have some examples in my demo. We'll go into a bit of the code there too. And Frank Herbert reference there. All right, moving on to Bulkhead Isolation. So this one's a nice one. It's sort of, I guess, a similar idea to Circuit Breaker. Circuit Breaker is, thread safe, and it's very sort of serial. So it's concerned about it when it gets an error, it will update how many errors it's caught, and it's doing that in a thread safe manner. So basically, like serial execution. So Bulkhead Isolation allows you to control concurrency for these downstream services, or rate limit, if that makes sense. So it comes from what boats have, and boats don't just have one big hull. Well, boats that don't want to sink don't just have one big hull. And so this little boaty fella is heading towards a reef, and he doesn't see it because his captain's drunk. Water will flow into this front guy, fill it up. But the rest of the boat has enough ballast so that it doesn't sink. And that's because we've segmented off the hull so to limit the damage that's been done. And in the same way, that's what the kind we want to do in our apps. We don't want a downstream service that requires a whole HTTP request, and maybe you get thousands of them a second and you're making thousands there. And you don't want that suddenly to fill up all of your I/O and memory consumption. You want to limit it and say, look, I'm allowing this much through to this service because I know that my servers are currently configured with X amount of RAM, and I know that they're running 2 other apps, or maybe they're running just this app. But you've figured out that for the health of your servers, that the amount of calls that you're willing to make to a particular downstream service is X. So hopefully that makes sense. I have an example here. So we're instantiating a bulkhead with a max capacity of 12. So that means that my bulkhead is only going to allow 12 concurrent executions. And I keep using this word thread safe. It's important, especially when you're talking about things like this. It's because if you create a bulkhead, if you knew a bulkhead up for each time, then it's completely useless. You need this bulkhead would have to be a singleton or some kind of reused object. Otherwise, it's completely useless. And the thread safe part is meaning that you're not going to corrupt the state of this object by accessing it at multiple points in time. So in this particular instance, we want 12 concurrent executions. And we have that number 2, which is how many we're allowed to queue up. And the number is low depending on a various different factors. You don't want to have this queue to be super high. Queues mean latency. So the goal of the queue is to keep your max, keep your parallelism to be maximum. So you want that 12 number to be as full as it possibly can for as long as it possibly can, including bursty periods of time. But if you start making this number too big, all that's going to do is make people wait a long time for something. And there is a balance here. So there is an event here called on bulkhead rejected. Now this gets triggered once that 12 and 2 number have been used up. So we have 14 sort of executions already going. At that point, we're going to throw this exception and also have an event here. In my example right now, I'm just logging it, relatively, mundane, but this is a good point in time to perhaps scale up your architecture. So you might say, okay, I mean, this is very reactionary. Hopefully you would have caught it at this point in time, but at some point you might say, well, maybe I need to scale up and add some more service to my cluster, or maybe I need to scale up the downstream service. And you can do that. So that would be like a reactive way of doing that. A positive way or a proactive way of doing that would be to check these current execution numbers, the bulkhead available count and the queue available count. And maybe you've decided that when my bulkhead available count's at 75%, that's when I want to scale up. I want to get ahead of the curve. And I guess you do have to be careful, especially with the queuing number. If the workload is CPU bound, a lot of the times having 20 times more CPUs than you have is all that's going to do is make your CPUs context switch and work extra hard to chew through. So really, this number, if it's CPU bound, you want it to be close to what your CPU count is. Just hopefully that makes sense. And then if it's something more like I/O bound and you're using async, and your framework supports that, or our framework does, basically you want, you can have threads awaiting, and you can still do other work. So you can change this number depending on the kind of workload that you're doing and how asynchronous your stuff is. And this is definitely something that you have to spend a lot of time tweaking and figuring out what's right. And we're talking about a bit of that in a little bit, because it's a whole other game to play. Like getting your strategy set up like this is one thing, but finding those numbers and how you configure them, when you configure them, it's a whole science to it. Well, so for CPU bound stuff, it would be the bulkhead isolation would be close to, I would say it would be the number of CPUs you have, or the cores, I should say, number of cores you have. Because any more than that, all you're going to do is you're guaranteeing that your CPU is going to have to context switch over and over again, and there's so much overhead in pushing stuff out of registers. So you want to at least give your code a chance at being optimum by doing that. Now, if it's I/O bound, yeah, it's really hard to answer that. I think on every occasion it's going to be different. I could throw a number out and say 1,000. That might be ridiculously large for your instance, or it could be small. I mean, there could be times when there's so much going through and your code is like optimal and great. 1,000 sounds about right. It's one of these things you have to kind of play with, I think. Anyone have any questions about sort of how to come up with these numbers, or even what, like a bulkhead? Hopefully I've explained what the bulkhead is pretty well. And so with this, it allows, like I said, you to rate limit downstream services, but you're also kind of helping upstream services too by making sure that your I/O and your resources on your service aren't ballooning out. So imagine suddenly a downstream service starts failing and all of our requests start backing up. We have this like longer queue, longer and longer, and all of a sudden all of our sockets, we've run out of sockets. And it happens within seconds. It can happen within seconds or minutes, very quickly. And then all of our upstream services are going to suffer too. And they could fail in the same way that we just failed. So you can see that downstream services definitely can affect upstream services, and this is how that cascading and rolling failure happens. So let's move on. Fallback is the things aren't going well. How do we at least fail somewhat gracefully? So in this here, we're looking for any foo exception, and once we have absorbed that exception, we'll fall back and log the warning. That's my go-to example. But maybe in this example, it's returning avatars. So I can imagine a time where like you're trying to load a profile of someone's page, and you don't want that whole page to crash. You just maybe inject a blank avatar. So at least you fail somewhat gracefully. I mean, they'll know something's up, but it's not a huge blank page. So basically here, trying to smooth out failure. So this goes to Paul's question, how do you start using these? And yes, they are great by themselves, but they become a lot more powerful when you start adding them together. So hopefully everyone can see this, but I have a fallback policy here, and it's looking for a string result, and it's looking for Redis connection exceptions, or a socket exception. So you can see here you can chain multiple exception types. And then once the fallback happens, again, I'm doing my favorite thing of just logging. Again, this would be a time to maybe alert people that things are really pear-shaped. And I might just bring up now, I'm using the Redis connection exception for a reason, because I kind of pulled it from some code that I was working with. So we're moving into AWS. My current team is the CI team, and we're on our way. And one of the security requirements is to have connections encrypted to our cache servers. And we're moving from Memcache, which didn't support that, to Redis. Now, we were starting to investigate the clients to use, and we ended up picking the Stack Exchange Redis client. It's great. It's very full-featured. It does lots of cool stuff. It's going to be part of my demo. It's also incredibly unopinionated, meaning that if something goes wrong, it lets you know about it. It does not do any kind of handling of exceptions. So our previous Memcache client, if something wasn't connectable, it'd be silent and just be a good little failure. And just because the way we use cache is that it's a nice to have. Our services aren't going to be as good without cache, but they're going to still respond. So it might take a second versus 50 milliseconds in those kind of ballparks. So it needs to get fixed, but things shouldn't completely blow up. And the Memcache client was easy in that if something wasn't up, something wasn't working, it would just fail, and it would just move on. The code would move on. But with the Redis client, not only do you have to be careful about the connection that it maintains to the server, you have to be careful and handle many different types of exceptions. So you're going to see some Redis exceptions in these examples, because that's what I was facing when I was sort of dealing with our resiliency strategy for our caching server. So the first policy is the fallback. Basically, how can we fail gracefully? The next policy is retry. As I described, we're going to be going through and attempting X number of retries. When something goes wrong, we log that and move on. And we are also looking for Redis connections exceptions here too. So that's a common theme. Hopefully that's the same throughout. Great. So the circuit breaker is the next policy to define. I've got some hard-coded numbers in here. You would probably not have these hard-coded in production. You'd probably have them in a config file, or have some cool like slidey knobby dial thing you have a UI in the admin section for if you want to be like agile. So our circuit breaker currently allows 3 exceptions before opening that circuit, and it will wait for 120 seconds. And I have these events here defined for each of the states. Basically, my favorite thing to do, log it. Now, each one of these things are great, but that doesn't solve my problem individually. I need to hook them up. So in Poly, we use a fluent way to connect them. So you can see I have my fallback policy wrapping my retry, which is wrapping my circuit breaker. And the ordering of this is incredibly important. So my next slide's a big, sort of like a flow diagram. and it's going to be very small to see, so I'm going to have to describe this to you. Basically, I have a call stack. From left to right, we are going from up the call stack down to the executed delegate that we want to handle. So to follow this through, our calling code executes, hits our fallback policy, which then passes that through to the wait and retry. Wait and retry does the same thing. It passes it to the circuit breaker. The circuit breaker determines what's the state of my circuit. Is it closed or open? If it's closed, we'll pass that execution down to the the actual code you're trying to run. Now, so if this works and this is happy, then we move on. None of these policies mean anything. The call stack gets traversed backwards and everyone's happy. But let's talk about when things go wrong. So in my previous code, I'm looking for the Redis connection exceptions. So let's imagine a Redis connection exception has been thrown by the code. Maybe the server's down. So the code gets passed to the circuit breaker. It, in a thread-safe way, will update the stats, meaning like basically bump the number of errors that we've collected. And then bubble that exception up to the wait and retry. Wait and retry will now do its thing and say, okay, I had an exception that I'm looking for. I need to retry this. So we pass it back down to the circuit breaker, and then the circuit breaker then executes it again. Same thing, number of times. And so from the previous example, my circuit breaker is configured to listen for 3 exceptions. And let's say my wait and retry was 3. I think it was 3. So this one request would actually trigger my circuit breaker from opening. And at that point, once we've opened that circuit, subsequent executions will immediately fail and we won't have to wait. So our third exception's happened and our circuit has been opened. That exception gets bubbled up to the wait and retry. It's exhausted its number of retries, so it gives up and it passes on the exception to the fallback, and the fallback catches it and goes, okay, things aren't going well. Let's fail as gracefully as possible. So with this sort of timeline, can anyone imagine what would happen if we rearranged it and say maybe had the circuit breaker and the wait and retry swapped? Anyone want to have a guess what would happen? Keeping in mind the ordering of these things and the call stack, the way that these things go. I know Etan knows. You don't know? So what do you think would happen if we swapped wait and retry with the circuit breaker? Can I bug you to guess? Sorry.
Thanks, Tristan.
No worries.
Can you repeat the question?
Oh, motherfucker. Oh, yeah. So they operate the same, no matter where you have them. It's just that I think your answer, it's close. I think you're hitting there. So a clue would be this moment here where it updates the circuit stats. So imagine in this diagram, the circuit breaker is here, and the wait and retry is the barrier right before the executed delegate. I'm sorry, if this is what you said, no, I apologize. So we're going to be retrying at that level. And so we've just hit our delegate 3 times. And when the wait and retry bubbles that, it's only recording 1. So that circuit breaker, 3 failures have occurred, but the circuit breaker is only catching 1. And generally, you could have it that way, and that may be how you want it, as long as you're consciously choosing that. But if you want your circuit breaker to only accept 3 failures from your downstream service, then you need to have it right next to the delegate, because the wait and retry is going to absorb, like a try-catch, absorb any of these exceptions and not bubble it up until its retry capacity is reached. Does that make sense a little bit? I was pretty excited about that one. I was pretty excited about this slide. Oh shit, maybe it was this one I was excited about. So I've kind of burned through the 6 poly strategies that I'm going to be talking about. I'm going to dip into a little bit of chaos engineering, a little bit of chaos monkey that Netflix has put upon us. So does anyone know what chaos engineering is, or chaos monkey in particular? I see some nodding heads. It's that this Netflix may not have been the first, but they're the ones that have kind of popularized, I believe, this idea of testing your resiliency. So all of these things before, all these numbers that I've chosen, they're all like cute. 2, 3. Wait 2 minutes. That's cute. Like, how do you know that? Were you doing load testing in your local environment and that's what you saw? Or are you guesstimating? I mean, that's what I do. I usually just guesstimate. I freely admit. But this is an idea of actually injecting faults at various levels, at various environments, to test what your resiliency strategy is. So a level 1 might be during some integration test, maybe it's in your unit tests, maybe it's during when you're doing load testing. That's something that I'm going to be doing more of. A lot of the times these days when I'm doing load testing, I kind of get things like I make sure all my applications on that remote server, it's in a really nice, healthy state. Everything's primo, pristine. There's nothing running that shouldn't be running. The network's open, making sure I can get the most throughput that I can to see like what's the best I can get. But maybe it's more useful to start injecting faults in there and maybe simulating some kind of real-world stress where not all TCP packets will get through. Sometimes things get turned off. So I'm going to be doing a bit more of that in my own local stress testing. Level 2 might be doing it in QA environments. So you might simulate a whole service being down in QA while the regression run is running and make the QA team extremely happy because it would ruin all their results. But it's a chaos monkey, and you can just say, look, it's for the greater good. Sorry, Frank. So QA, and then level 3 would be then, for real, you've grown a lot of trust with your resiliency strategy. You think you can handle what the world has to throw at you. Let's start turning stuff off in production. Of course, we're talking actually about an abstraction of actually doing real world things. So you can abstract things like turning a power outlet off, turning an Ethernet failure, dropping packets, killing an availability zone. These are sort of the concepts that you can simulate in the greater chaos engineering sort of mindset. Yeah. Thanks. Thank you, Mina.
Would you do this in it says production monkey, but would you rather do this in a war room or somewhere where you'd have a isolated system where?
Yeah, I think that sounds about right. There's probably level 4 levels. I just made this shit up. So level 3 probably is like do some kind of isolated production test. And level 4 would be like, nah, these are all levels that you have to like graduate from.
Right, and
Netflix,
right? The folks at Netflix developed the Chaos Monkey thing, and they do run it in production, right?
Exactly, they totally do.
You can just, I think they can restrict the scopes of the things you could possibly break. But the best value you're going to get is by running something like this in your production environment, right?
Exactly.
How many times have you tried testing in some dev or QA or staging environment,
and it's all
and
just
then
simulation.
it never matches what's actually in production.
It's all just simulation.
Yeah, so that's the cool thing about the whole Chaos Monkey its real value is it's running in prod. That's fun.
Yeah, it's real world experiments, not just in a petri dish. Yeah.
So when the shit hits the fan, you know what the hell is going on.
Well, hopefully you've actually thrown the shit at the fan yourself a few times, and so you kind of know the spray pattern and to like duck the chunks. I'll leave that alone.
There was a Super Bowl commercial. Yesterday about the stuff hitting the fan. And
oh yeah, well there you go.
just need
timely.
a lot of paper towels and other products to
timely.
clean it up.
Well, I know what we have here. We have ways of sort of replaying production-like scenarios here by we keep a stack of HTTP requests, because a lot of the time, as a CDN, we're servicing HTTP requests. It's a lot more complicated than that. I don't know enough about it, but we keep logs of all these things, and we're able to replay and kind of get production-like sort of replays. But at the end of the day, it's still not the same thing. And you don't want to go wake up one day, cool, I'm going to start breaking stuff in production. That's not what this is about. It's building this level of trust, and you know what happens when this turns off. You just want to see, you want to verify what happens in production. So I have, actually a bit of my demo is going to be, sort of the more interesting part of my demo is going to kind of be this fault injection. Well, it's interesting to me at least. PolySimi is the poly addition that can help you with these things. And it lets you do 4 different things: inject exceptions, inject results, basically swap out a good, like an actual result for a fake result to see how your code will handle that. You can inject latency, just slow things down. Or you can actually inject extra behavior. So behavior is similar to result. It's just that you're not replacing that, you are adding on. So you're adding more weird junk into your code. So any questions on any of these? I'm going to go into a bit of an example, I think, with the behavior, exception, and latency in my demo, which is right now. Hey, Tan. That was mainly just to get Tan's reactions. Worth it. Well, yeah, there's a solid chance during live demos that things will break. So my demo is comprised of 2 parts, and one of those parts is comprised of 2 parts. So I have a simple sort of HTTP client example, mainly because I see these days it's a very easy thing to misuse. You want to make a call to another service? Okay, well, cool. I'm going to new up an HTTP client, and I'll make sure it's in a using block to make sure I want to dispose of that. It's wrong. You're gonna have problems in production. So it's one of these things you can get wrong very easily. So I'm gonna go into a little bit of details about the HTTP client factory and how to integrate Poly into the HTTP client factory, which is currently the best practices approach to getting new HTTP clients. And the second part is I'm kind of going for like a TV station and a TV kind of analogy, where I have a console app that's acting as a subscriber to a particular channel on my local Redis instance that I'm running. And then I have another console app that has 8 frames that is going to repetitively push through the Redis channel, and the subscriber will pick that up. So I'm going to dive into that one first because it's more interesting. So I have on this top left console app is my subscriber. Currently, imagine that's like signal's dead. TV is off, or it's like that, what do you call it? The white screen, white snow. White noise, I got there eventually. So right now, there's no signal getting pushed. And in this bottom console app, I have a publisher, which, like I said, has 8 frames. One second. I just want to make sure that it's happy path right now. I'm going to dive into the code. I just want to show to you quickly while things are working well. Okay, so it's going to be pushing those 8 frames into my Redis channel over and over and over again, and subscriber will be picking it up. So this is what it looks like when things work well. Hey, didn't get killed. So I have increasing opaqueness, and then some beautiful ASCII art going poly, 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 poly. bing, 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 poly, 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 poly. So it's happening at a regular tick. I think it's about 600 milliseconds. You can see it's relatively smooth, not seeing any service interruptions. This is when things are working lovely. This is my local environment. I'm ready to go to production. I'm ready. Let's go. But maybe I want to do some more testing before we do that. So let me run over the code a little bit if anyone's interested. Hopefully we are. So my subscriber is a bit more of the boring one. I have a startup class in my console app, and it's instantiating a console app instance. This is where the bulk of the work gets done. This is the main meat and potatoes for the subscriber, where I am subscribing to a Redis channel, messages, and then just waiting for input. That's just so my console app doesn't just quit out straight away. So every time a message comes through, I clear the console. I take the message that was passed in and display it to the console, and then I just wait 100 milliseconds. So nothing too interesting here. I didn't add a whole lot of resilience on this side of things. I have sort of other startup classes with resiliency, but I found it more fun to add the errors and the resiliency into the publishing side of things. So for the publisher, I'll show you the meat and potatoes here, where we have an infinite loop going through. I don't know if you guys can see it on the right, but I have basically an array of strings that are my frame, like simulating a frame. And so I am going over each message in messages, taking that string, pushing it onto the channel, and then just looping over that forever and ever and ever and ever and ever. Amen. Each in between, I'm waiting 600 milliseconds. So to the interesting stuff, in my startup class, this is where dependency injection is happening. I'm adding logging. I'm doing some other service resolution and these kind of things. I'm not sure if anyone's interested, but this is just sort of your average Microsoft dependency injection stuff. If you are interested, I do have a Git. This is hosted on GitHub, so you can download this and play with it yourself. But getting to the poly stuff, I have a retry policy. I am looking for a Redis connection exception. I am looking for socket exceptions. If either of those two exceptions happen, my retry policy is going to absorb that exception and retry the delegate. In this case, it would be resend the message onto the Redis channel. I'm using just retry in this example. I was hoping to show even just the power of having a retry. And so here, this is where I'm starting playing with some of these fault injection stuff. I'm defining my errors that I'm going to throw as a socket exception of 10013. And if anyone knows their socket exception codes, I hope everyone knows that this is a security denied. I'm not seeing many nodding heads. I'm ashamed of you all. So I have a chaos policy. So this is going to be the one that determines how many and what kind of exceptions to inject into this policy. I also have a latency policy. It does exactly what it says on the tin. And you can see each of these things I have configured with this configuration class that gets bound to my app settings file. So my app settings file has resiliency configuration, and a property of retry count, retry delay milliseconds. So right now, I'm going to be retrying 3 times, and I'm going to be waiting 10 milliseconds because I'm impatient. Fault rate right now, 0. We didn't inject any errors. I have my latency set up for 2,000 milliseconds, but currently I'm not injecting any. Same, I have another type of Chaos Monkey stuff where I'm actually injecting a separate result. So down here, I had to move this into a separate part of my code. I have a policy, a monkey policy, that's going to inject behavior, which means it's not replacing anything, it's just adding extra on. So instead of getting the 8 frames, a percentage amount of the time, we're going to get an extra frame. And also add some logging because that's my thing. You can see here, if this is interesting, we're setting the injection rate from that configurable value that was in my app settings, and then making sure it's enabled. I'm doing the same thing where I'm wrapping things in a intentional way to get the behavior that I want. And I'm using that policy to push things to the queue. So I'm going to start playing with the errors now. Let me close this down. So I'll start with, again, I'm injecting socket exceptions. So I'm going to start at 30%. 30% is a lot. If you're getting a 30% failure rate, it's a lot. But assuming that it's a random error rate, so maybe like three of your 10 servers are bad, and that you have your load balance is going to round robin, and so it's a sporadic error, and as soon as a request goes to one of those 3 bad servers, you get an error. This is a similar situation. So right now, injecting 30% of the time, so 3 out of 10, I'm going to be injecting a socket exception. So, and as soon as an exception is injected, you're going to see a white line in the info log. And as soon as you see a yellow line, that's when a frame has been dropped. That's when the retry count was exhausted. We were bad enough luck to have 3 consecutive errors. I forget, the odds would be like 0.3 times 0.3. And anyways, it's not that often. So we just got 2 errors in a row, the first retry and then the second retry. But as you can see, with 30% error rate, the retry is actually able to smooth out these errors, and you're not actually able to really tell much difference. This signal is what it looked like when it was at 0. We haven't dropped a frame yet. It eventually will. I don't necessarily want to sit around and wait for that. So let's start forcing things to happen. So anyone want to throw a number or a percentage out they want to see other than 100? 75 is a good number. Thank you, Delari. So let's see so this means 3 out of 4 of these requests are going to throw a socket exception. I don't know if it's like about you, but like in my head, I'm imagining complete catastrophic failure. And it's not going to be great, I'm not going to lie. Every time we see a yellow line is when a frame gets dropped. But as you can see, it's somewhat like acceptable. It's not great. But yeah, this is in a situation where maybe you have 7 out of your 10 servers are bad. They got a bad build because we released wrong. The canary's gone wrong and the canary's falling over. And this is the scenario where the round robin is only succeeding 3 out of 10 times. With a retry, it's pretty okay. So I think you can all imagine what it would look like at 100%. So there's that. So I have fault set up. Let's drop that back to 0. So that's what playing with that fault rate looks like. You can inject all kinds of exceptions that you like, and you can have delegates that run when that happens. Any questions on the fault exception injection? So I'm going to move on to the monkey injection rate, which I think is a pretty cool name. So I'm going to be injecting monkeys. So keep an eye out, because 30% of the time, I'm going to be injecting a monkey. And when's the last time you injected a monkey? Exactly. Oh, it came right off the bat. And so every time I inject a monkey, I also write a line to the console app. So it's hard to kind of tell, but this isn't replacing any of the frames. This is in addition to the frame. So we're going to get the full 8 frames plus the monkey frame every 30% of the time. If I was to use the result injection, we would be actually swapping out one of these frames and replacing it with a monkey. So it would be a monkey replacement versus a monkey injection. So that is my so far I've got. Does anyone really want to see latency? It's really not exciting. You just sit and you see nothing for 2 seconds. So similar to monkey injection, other than it's just instead of injecting monkey, you're sitting around for 2 seconds. So not that exciting in the demo, but again, if you pull this down off GitHub, you can play with this yourself. So that is my that's my exciting demo. So if that didn't tickle your jimmies, then I got bad news for you, because this one's more boring. This one was because I found a lot of people, I mean, it's something you can easily get wrong. It's the HTTP client usage. All right. Most of the interesting stuff here is happening in my dependency injection. Startup class. So, oops, that is in the way. I am setting up my retry policy in this first block. You notice this doesn't have poly in it because we are using the Microsoft the poly HTTP extensions, which play nicely with the HTTP client factory. We are handling transient HTTP error. It's a very nice, user-friendly way of saying 500s. Probably some other ones I can't think of right now. Probably some 400s, maybe rate limited. 429 probably would be a transient. I think a lot of 400s may not be transient, but some of them are. So someone's been the poly contributors have been nice enough to go and enumerate the HTTP errors that are thought of as transient. And I'm also adding in a socket exception. So I'm looking for any transient HTTP errors and socket exceptions. And I am wait and retry a configurable amount of time. I'm waiting for another configurable amount of time, and then on retry, in addition to actually retrying, I am logging this attempt. Just quickly, I'll dive into the configuration file. So it's a similar thing to the previous one. I just have some values here that make configuring the client a little bit easier. Wrong place. So I also now have how do I make this big enough? I have a circuit breaker set up. I'm still using the HTTP policy extensions to generate this. And that's because these objects work nicely with HTTP client factory again. The poly objects don't. So setting up my circuit breaker, setting a delay, setting what to do when the different states occur. And then I am wrapping my retry with my circuit breaker, meaning conceptually imagine like the Russian stacking dolls. You've got the retry that sort of absorbed the circuit breaker, and then as the calls come down, they get passed down that stack. So I have 2 examples here of adding and configuring HTTP clients. It's a great place to do it in dependency injection. Having this scattered all over the place makes it hard to manage. It means it's more easily error prone. I don't know about you, but like looking at a class that is doing like 5 to 10 different things, it's very hard to do a code review on that. So it's easy to, if you've got some class and then like some business logic and it needs an HTTP client, and it's doing some manual configuring of that client in that, you've got 1,000 other things to look at to code review. So this increases visibility. It makes one place. It's a one-stop shop for all your HTTP clients. It means that yourself and other members on your team are going to be using things in the best practices way. So you can see I'm setting up HTTP client for dependency injection. So if any instance of something that is implementing the iRepo service or the Git repo service itself, this concrete class Git repo service, when it wants an HTTP client, it gets this particular one. And you can see that I'm configuring the base address here, which was the api.github.com, and adding default request headers. You can do whatever you like in here. There's a whole bunch of configuration options. Question?
Is this the HTTP client factory?
Yes.
Thank you.
Yes. And it's a nice way of handling it. I'll just quickly dip into what can go wrong when you instantiate a HTTP client every time. Mainly slow. The actual class HTTP client isn't that slow to instantiate, but it has some child objects to do with request handling that take a long time to set up. Even though it implements the iDisposable interface, the way it was coded was that it disposes things, but it leaves a socket open for any trailing messages from that remote downstream service. So it's almost just like a safety catch to be like, just want to make sure that you got nothing else to say, and it'll hang out there. I think, but by default, it's like 2 minutes. So if you get a bunch of things and you have a using var new HTTP client, you're going to exhaust your socket exceptions. You're going to exhaust your sockets pretty quickly. And the other thing is, so the other solution to that is to use a singleton, which is pretty solid, and it covers most of the scenarios. HTTP client is thread safe, so it's fine to have one HTTP client for your whole app. The only issue that I've read about that Sadai mentioned was that when it resolves DNS for an address, it will cache that to try and save time. And as far as I know, there's no way to flush that cache other than an app cycle restart. So you might get stale DNS on that HTTP client if you use the singleton pattern. So the first option was using dependency injection. I'll show you how we use that. And then we have a named client where you can reference this. You can get an instance of this HTTP client just by using GitHub repo client. You can ask, give me a GitHub repo client, and it'll give me the client that gets generated from these methods. And so I do something similar where I'm setting a default header, and then I'm adding. I thought I'd just show another quick way of adding the retry. You can add transient HTTP error policy, like so. Circuit breaker, and timeout. Very similar to what I was doing above, just a different way. Any questions on this before I show how the thing gets used? So this was in my startup class. This gets run once. Yeah.
How do you identify GitHub repo client? I mean, you're putting it in there as a name. Where is that indexed to?
Yeah. So this is using magic strings, and you probably don't want to do this. You might want to have like an enum somewhere of some strings, but essentially you're adding it. It's almost like it's like a repository. I didn't want to use that word because it's the GitHub repo client, but you're adding it to a collection. There you go, of HTTP clients that you define, and you allow your HTTP client factory to spit out. So to use that. I have my Git repo service, just so you can get an idea. Here's the interface in the same class because I'm lazy. And the Git repo service is implementing iRepo service. It has an HTTP client that will be used for the dependency injection of the first HTTP client that I set up. And it also has a dependency on the HTTP client factory. So whenever a Git repo service gets instantiated, the Microsoft dependency injection will plop in the client that I set up in my startup class, and it will also plop in the implementation of the HTTP client factory. So if you can recall in my startup class, I have the dependency injection example and the named example. So in this first method here, I'm using the injected HTTP client, which got injected because of the type this class is. And so you can see this code is pretty clean. There's no retry logic here. There's no using statements. It makes your service class. I mean, I made this like a one-tier application. You could bury this in some business layer if you wanted, or some other architecture. But at some point, you just want like a nice, easy, readable what is this thing doing? And so here it makes it nice and simple. It's streaming orgs.net repos. It's making a GET request, and then it's deserializing them and returning them as a collection. So the second method here, this get repo readme, it's actually using the HTTP client factory itself to create the client. And here it's using the same name. So again, you probably wouldn't use an actual like string. You might want to have that somewhere defined. So it's asking the factory, hey, give me a client for this. Once it gets that, it can use it in the same way as in the previous example. So again, no retries, no resiliency strategies messing up your business logic. It's all baked into wherever you need it to be. In my example, I had it in the startup where I do my dependency injection. You could break that off into its own thing for sure. I know Greg has wrappers for his wrappers. So he finds that the, I don't want to misrepresent, but you maybe find the poly expression a little wordy, and so you have a wrapper on top of that to make use of that even easier. So these things are all totally configurable into your complete taste. I kind of like how this one works, and I think I've run out of demos, and I just have leftover junk. So some links, some information about integration with HTTP client factory and Poly. If you are in a lucky enough position to be able to use .NET Core, highly recommend using the HTTP client factory if you need it. A quick mention is like I think the way to use that is using the Microsoft dependency. So I'm not sure how well it works with something like AutoFac, but at your own risk, and just some other examples for playing with the chaos.
I'm sorry, in the beginning you were mentioning about the versions that you can use the Poly with the .NET.
Yeah.
.NET frameworks 2.2 and
Yeah, it's
how about
standard
the
.NET.
3
I think it's target standard 1.0, or is it 2?
because I didn't see 3. Or maybe you didn't put it.
Well, as in .NET Core 3, but so .NET Core 3 uses .NET Standard.
Okay.
So you can pull it. I'm running it. These examples we're using .NET Core 3 and C# 8.
Okay.
So it's usable in anything other than like .NET 2 or 3.5. Do I have any other questions? About to wrap up and. Paul.
Art, is there a PDF of your slides?
No. I don't know. Oh, I have a video of myself. What? Oh, I can put the slides on GitHub. Do you need it to be PDF? Or is it like a PowerPoint thing? Oh, slideshare.net. Yeah, we'll do. I'll add it to the meetup page.
I don't want to steal your slides, but
Feel free.
I'd like to get these links.
Yeah, totally.
I could just photograph them, I guess.
Well, yeah, but it's like just the words. I realize that's a bit silly. I'll put these slides up on the meetup page. I'll link them there so you can see it from there.
Thank you.
Yeah, no worries. All right, well, thank you for coming. No questions, but all right. Thank you very much. Which one is that? Oh, shit. Oh, yeah, Carl Franklin. Yep. Blazor. It's a way of running .NET code and having it compiled into WebAssembly, so you can have code run in your browser and have your unit tests test your UI and your backend. So it's going to be 3 hours of content, I believe, Greg. It's going to be coffee might be we have coffee in the kitchen. It might be a useful commodity. So it should be a great talk next month. Hopefully see you guys there.
Yeah, and also if you're into MuleSoft, which is some software for business app stuff, we're hosting a meetup here March 5th. And what's the date on that next .NET meetup?
I think it was the 3rd of March.
Yeah, that's right, March 3rd.
And
Very
it's the
good.
change in time to 6 p.m. And it's a
And
Tuesday.
it's a Tuesday.
2 changes.
And we'll probably live stream that one as well, in case you get the date wrong.
I think, yeah, we'll connect up. But awesome. Thank you, guys.